Welcome back to yet another video from my side. Now you must be wondering what this caption is for the opening slide, the mass status dash in schools. Interestingly, this video discusses mass that is never taught in schools. This is actually a fun video which I just made it to for children to kind of sit back and relax and enjoy mathematics from a different perspective. Now, we must have often heard the word maths or mathematics, and alternatively in the United States, teachers and students and principals, they use the word arithmetic. What's the difference between the word maths and arithmetic? Let's have a look at it. The word maths actually means to learn, and by the dictionary definition, a polymath is a person who's very learned. Let's look at what the word arithmetic means. The word arithmetic means the science of numbers, and it comes from the Greek word arithmos, which literally translated into the English language means numbers. Let's look at the names of the four primary maths operators. Now, if you were to go back to maybe class 1 or class 2, we learned how to add, we learned how to subtract, we learned how to multiply and then divide. So we had signs like plus, minus, multiplication, and the division sign. Is there a name for these symbols? Yes, of course. The first symbol, as you see, is the plus sign, and in the world of mathematics, it's called the St. Andrew's cross. The symbol minus sign is for subtraction, and it's called the hyphen. The multiplication sign is the X sign or the into sign, and it's called the saltire, and it actually comes from the Scottish flag, which also looks like the letter X in the English language. Finally, we come to the division sign. The division sign in mathematics is actually called an obolus, and the plural for obolus is obuli. Let's look at the constituents of addition. So let's say we are adding two numbers, 2 plus 3. What does 2 stand for, what does 3 stand for, and what do they collectively stand for? The first number to which the other numbers are being added is called the augend. So over here 2 is the augend, and collectively 2 and 3 are called the addends or the summands. Let's move to constituents of subtraction. Supposing I am subtracting 2 from 3. So what's the mathematical word for the number 3 over here? It's called the minuend, and the number 2 is called the subtrahend. Let's look at the constituents of multiplication. Let's say we are multiplying 3 by 2. 3 is called the multiplicand and 2 is called the multiplier. If 2 were being multiplied by 3, then 2 would be the multiplicand and 3 would be the multiplier. Let's look at the constituents of division. Supposing I were to divide 3 by 2. So 3 is the dividend, 2 is the divisor, 1 is my quotient, and 2 times 1 becomes 2. So we subtract 2 from 3 and 1 becomes the remainder. The equal to sign, this is quite interesting. It was introduced in mathematics, or rather in the world of mathematics, only in the year 1557 by the Welsh mathematician Robert Recorde. And Robert Recorde also gave the plus symbol in mathematics. Prior to the parallel equal to sign, what mathematicians were using, they were actually writing is equal to. So Robert Recorde found out a shorter and a smarter way to mention the words is equal to. What are vinculums in mathematics? The first thing that we need to know over here is that a vinculum is a Latin word which means to tie or bind, just like you tie your shoelaces. And vincula is the plural of vinculum. Let's look at some examples of vinculums used in mathematics. In the fraction 1 divided by 2, the yellow colored line, the horizontal line in fractions, which differentiates the numerator from the denominator, is called a vinculum. Vinculums are also used above repeating decimals. So in this case, we have 0.123, again 123 is being repeated. So instead of repeatedly mentioning or writing 1, 2, 3, we can knock off the excessive 1, 2, 3s and just put a horizontal line like I have put it over here over 1, 2, 3. Above the radic sign, 16, the yellow sign which you see, the symbol on the left is called the radical or the radic symbol on the left of 16, and the yellow line above 16 basically which shows that these numbers are tied together is called a vinculum. Then above the letter x or a variable x in statistics, this denotes a mean. So that's also a vinculum. Let's look at the integral symbol. You must have seen this in calculus in class 12 and class 11. This is what it looks like. And basically it is nothing but it comes from the Latin language and it's the letter long S. And this letter long S is short for summation or summa. And interestingly, it was introduced by Leibniz in modern mathematics. And Leibniz, as you know, was a contemporary of Newton, and they both together they developed a lot of formulae and a lot of applications of calculus. You must have heard of the second word hypotenuse in geometry. In a right angle triangle is the longest length of the right angle triangle, or sorry, the longest side of a right angle triangle, and is the side which is opposite the right angle triangle. Now interestingly, hypotenuse is not the original word. The original word is hypotenusa, which comes from the Greek language, and when it was taken over by the French people, it came to be known as the hypotenuse. And the original meaning of the word hypotenusa is actually Greek for stretching under. You must have heard of a prime number. By definition, a prime number is a number which is divisible by itself and by the number 1. And most students make a mistake. They say that even the number 1 is a prime number. 1 is neither prime nor composite. There are several kinds of prime numbers. In fact, there are certain prime numbers which have been named after mathematicians. But I've just picked up 3 prime numbers over here. Let's look at the first one, the cousin prime numbers. These are prime numbers which are differing by 4. For example, 3 and 7, 7 and 11. These are cousin prime numbers. Twin prime numbers are prime numbers which differ by 2. For example, 3 and 5, then 7 and 9, then 11 and 13. These are twin prime numbers. Finally, palindromic prime numbers are similar to palindromic words. Like the word radar, it can be spelled the same forwards and backwards. I've given 2 examples of palindromic numbers over here. One is 11 and the other one is 101. So if you were to read them forwards or backwards, they would read as the same number. What is ellipsis in mathematics? Let's look at this series equation. It's quite evident that this is a summation of odd numbers beginning at 1 and ending at 99. But what I have done is I have put some dots in the middle. I missed out these specific numbers. But it's quite understandable that these dots represent 7 plus 9 plus 11 plus 13 with the difference of 2 going up to plus 95 plus 97 and then finally terminating in 99. These omission of data in a series etc. and their representation, the representation of the omitted data is called ellipsis in mathematics. What does this symbol M perpendicular n actually stand for? We know that this comes from geometry. It means if 2 lines are perpendicular to each other, we represent it by this symbol. But what if we were doing algebraic mathematics or numerical mathematics? Basically, if we show 2 numbers m perpendicular to n, it means they don't have any common prime numbers, or these 2 numbers are relatively prime. Very important concept. E and ln functions, they cancel each other. Very useful in class 12 integral calculus. E to the power of ln within brackets of a function called 2x is nothing but equal to 2x. Similarly, when I say 10 to the power of log 2x, this is nothing but equal to 2x. What is a cathetus in a right angle triangle? You must have heard of the hypotenuse. But what is a cathetus? Let's look at a right angle triangle. There we are. The longest line is the hypotenuse. bang opposite the right angle, the 90-degree angle, and the base and the height of the right angle triangle, both these sides are called the cathetus. And if you were to talk of them in plural terms or jointly, they are called catheti. What does the word quadratic mean? Linear equation is understandable, it yields a line. A cubic equation is understandable because it has the highest degree, power of 3 or the exponent 3. Let's look at what the word quadratic means. It actually comes from the word quadrate, which is a noun and it means a four-sided figure. And the word quadrate is also a verb, which means to make something into a four-sided figure. Let's look at a classical example. We have a square. All the four sides are of x unit dimensions. And supposing I were to transform this square, in fact over here I'm looking at the second application of the word quadrate, the verb. I'm actually doing an action on this square. What I'm doing over here is I'm reducing one side of the square by x minus 1 units, and I'm stretching the other side by 2 units and making it into x plus 2 units. So if we were to calculate the area of the rectangle so obtained, what we get is x minus 1 multiplied by x plus 2, which is equal to x square plus x minus 2. And what is x square plus x minus 2? It's nothing but a quadratic equation. I have a square which has been quadrated into a rectangle. What is a sphenic number? It's a number which is the product of three prime numbers, three different prime numbers actually. The smallest sphenic number in mathematics is 30, which is a product of 2 multiplied by 3 multiplied by 5. And these are the starting three prime numbers. So obviously the product would also be the smallest sphenic number. This symbol, if you look at modern computer keyboards, would be just below the escape key and to the left of the 1 and the exclamation mark or the factorial symbol key. This is called as a tilde and it comes from the Spanish language. Actually, tilde is a negation operator. So tilde q represents the set of non-rational or irrational numbers. The letter q, capital Q, represents the set of rational numbers. And I will explain shortly why we represent the set of rational numbers by the letter q and not by the letter r. The letter r stands for real numbers. What are Amblygon and Oxygon triangles in mathematics? An Amblygon triangle is a triangle in which one angle is actually an obtuse angle. And logically speaking, the other two angles would be acute angles. The Oxygon angle, all angles are acute angles, are called Oxygon triangles. Isosceles triangle. The word isos means both or two, and sceles actually stands for legs. So the two sides which are equal in dimensions are called isosceles triangle, and the third side is called the base of the isosceles triangle. Let's look at the Pascal's triangle, which is taught in class 11, and its relationship with 2 to the power of n. Let's look at a polynomial, which is actually a binomial because there are two distinct terms a and b. And supposing we were adding up a plus b, raising it to the power of 1, we would get a plus b on the right side. Supposing these binomials were added together and raised to the power of 2, we get this classic equation a square plus 2ab plus b square, and this is something which you would have done in class 9 and class 10. Moving on to a plus b whole cube, we get the equation a cube plus 3a square b plus 3ab square going up to plus b cube. A plus b to the power of 4 is a to the power of 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b to the power of 4. Let's look at the extrememost column. If I were to add up the coefficients of a plus b, which are 1 and 1, so 1 plus 1 is equal to 2, which is equal to 2 to the power of 1. Coming to the second row, the coefficients are 1, 2 and 1, So if I add up 1 plus 2 plus 1, it becomes 4, which is nothing but 2 to the power of 2. Coming to the third row, the coefficients are 1, 3, 3 and 1. If we were to add up 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 1 is 8, which is nothing but 2 to the power of 3. Finally, coming to the last row, the coefficients are 1, 4, 6, 4, 1. And if you notice, they're all palindromic. I can read them forwards and backwards and they're the same. So 1 plus 4 is 5, 5 plus 6 is 11, 11 plus 4 is 15, and 15 plus 1 is 16, which is the same as 2 to the power 4. It was this Pascal's triangle which helped build the binomial theorem. And if you are in class 11 or you're beyond class 11, you would have studied the binomial theorem, which goes like this, that x plus y to the power of n is equal to nc0, x to the power of n, y to the power of 0, plus nc1, x to the power of n minus 1, y to the power of 1, plus nc2, x to the power of n minus 2, y square, going up, followed by these ellipses, the three dots, ncn, x to the power of 0, and y to the power of n. What's a lemniscate in the world of mathematics and also in physics? This symbol, the digit 8 placed horizontally is the symbol for infinity. It's called a lemniscate. What is GMOS? I mean, any English language speaker and a non-French person would obviously, take it, pronounce it as guillemets, but I was corrected once. And basically, these are punctuation symbols in French language, and they're used for less and greater than. And basically they're pronounced as emo. What are the three laws of numbers? Often I ask children, in class 7, class 8, and they're quite confused and have forgotten which are the three laws of numbers. And I'm presenting over here in a fashion in which you will never ever forget what the three laws of numbers stand for. The first law is associativity, and it comes from the word association. The second law of numbers is called commutativity, and it comes from the word commuter. So 1 plus 2 is the same as 2 plus 1. The binary operator plus remains in the middle. 1 swaps places with 2 and 2 swaps places with 1. Distributivity comes from the word distribution. This is very interesting. The trigonometric ratio sine pertains to a triangle. Cosine also logically pertains to a triangle. But surprisingly, tan and secant, they do not pertain to a triangle. Let's look at this right angle triangle over here. We have, three sides A, B, and C, and we have the angle as x degrees. Sine of x is nothing but A by C. The cosine is B by C, and the word cosine actually means sine of the complementary angle. Finally, there are circle concepts in trigonometry. The word tan comes from the French word tanguer, which means to touch. And secant comes from sequer, or it means to cut. While logarithms were invented in mathematics, they were devised by John Napier. He was a Scottish mathematician, lived between 1550 and passed away in 1617. Basically, it was to abridge arithmetical calculations, numerical calculations, by the use of addition and subtraction in place of multiplication and division. What are common logs, what are natural logs, and what are binary logs? The common log is represented by these three letters log. The natural log is represented by the two letters ln, and binary logs are logs to the base 2, to the number 2, and they're represented by lb. And interestingly, binary logs have an application in the world of music, and Euler was the one who used binary logs quite a bit. Why do we have n as the set for natural numbers, w for whole numbers? All that is understandable. But why do we have q for the set of rational numbers and z for integers? Very interesting. Q is used as a set for rational numbers because rational numbers yield a quotient. And if you notice the word quotient, I have marked it in light blue, and that's why it's called the set of rational numbers, represented by the English letter capital Q. Why Z for the set of integers? Now Z actually comes from a German word Zahalane. The two dots above the letter A in Zahalane is actually a Germanic, it's called a diacritical mark, and it's called an umlaut, umlaut. So basically, the set of integers, it represents a set of counting numbers. That's why it's called Z. The symbol pi in mathematics, this is small case pi. Interestingly, pi has been known to humankind for almost 4,000 years, but it was not until 1706, so less than about 314 years back, a British mathematician by the name of William Jones, he started using the small letter pi in the world of mathematics to represent the constant 3.14159, which is nothing but in a circle the ratio between the circumference to the diameter of a circle. Now there is a function called the pi function, again smaller case pi. This pi function is used in mathematics to count the number of prime numbers less than x. So if I were to run a function called pi of within round bracket 7, it will give me the answer as 3, because within the curly brackets you will see that there are only 3 prime numbers which are less than 7, 2, 3 and 5. So it gives the number of prime numbers less than the number within the pi function. Surprisingly, pi is not getting relevant anymore. The Greek letter tau is a suggested symbol for the ratio of circumference to the radius of a circle, and this constant is equal to 2 times of pi, and it is approximately equal to 6.28. Why the letter C for radians? We know very well that degrees are represented by a circle or a dot. So 180 degrees is what you write as what's written on the left hand side. Now pi radians is written as pi to the power of C. C over here is a superscript. The reason is C visually represents an arc of a circle, and if you go back to the definition of the radian, an angle which is subtended at the center. So 1 radian is equal to 1 arc length divided by the radius of a unit circle, where the radius is equal to 1. So from all the 26 letters of the English alphabet, starting at A and ending at Z, is the letter C, which closely represents an arc of a circle. Very interesting, the only mention of the digit 0, as you must be aware, Indians invented the digit 0 and the decimal system. So this digit 0 is found at the Chaturbhuj temple at Gwalior Fort, and is the oldest epigraphical mention of the number 0. And Albert Einstein once remarkably remarked about mathematics and Indians in particular. He said that the Indians were the smartest people because they invented 0, and without the invention of 0, no physics and no mathematics would have been possible. Let's look at Euler's contributions. Leonhard Euler was a Swiss mathematician. He mentioned the symbol E for the constant 2.7818. I've explained it in another video what exactly is E. He also mentioned about using the letter small I for imaginary numbers, which are also known as complex numbers. Then fx for functions. Then capital sigma for summation, and ABC as constants, and XYZ as variables. My name is Vishal Bhatia. I did a Master's in Accounting and Finance from the London School of Economics. You may WhatsApp me. I only accept text messages on WhatsApp. +91 is the country code for India. My WhatsApp number is 98710 59470. Thank you very much.